All right. So happy Monday or Tuesday, depending on when you're watching this. So this is your accelerated geometry review. Remember your test is on Wednesday, so that's coming up. So we're gonna start off with craft toy wagons are made to sell at a craft fair. It takes 4 hours to make the small wagon. So it takes 4 hours to make the small wagon. Okay, I'm sorry. X is gonna be the small. And then we got a large wagon, which is going to be our large one, our Y value. So it takes 4 hours to do the small one. It takes 6 hours to make the large one. A craft booth owner has no more than 60 hours available to make the wagons and wants to have it at least 6 small wagons to sell. So we're going to write our little possible constraints, and then we're going to try to find one solution that works, or it could be multiple solutions. All right, so first we've got at least 6. Okay, so we can have 6 or we can have more than 6 of the smaller ones. Okay, but if we're writing out the other constraint, they said, oh, we only have 60 hours available to make the wagons. So we've got 4x plus 6y, because it takes 4 hours to make a small, 6 hours to make a large, and we're going to say less than 60. Okay, so that's what these two lines right here represent. Okay, so it's got to be less than 60, but greater than 6. So anything that's inside of here would work. Okay, so if you picked a point, let's say you picked 8, 2. Let's see if that works. So if I picked 8 of the small ones, okay, so I'm going to plug 8 into this inequality and see if it works. So 8 into the small ones, and then 2 into the large ones. Okay, so 4 times 8 is 32, and 6 times 2 is 12. And if I add those together, I get 44, which is less than the 60. Okay, so that's a possible solution. Okay, but you could pick anything that's inside here. You want to make sure that you've got whole numbers though, because you can't have half a wagon. Okay, it doesn't work. Okay, so whatever you pick, it's got to be whole numbers. Okay, best case scenario would probably want to be this 6, 6. Okay, but they do want less than 60 hours, so it might fall a little inside of that as well. Again, you can pick any of those situations. Okay, so let's go ahead and look at number 2. Okay, so on number 2, sorry, my door is open. If you hear background noise, it's not my fault. Okay, so a baker is selling 2 types of donuts. We've got glazed donuts, which are G's, and we got jelly donuts, which are J's. Okay, if a customer wants to buy no more than 13 donuts, so that means that G plus J is less than 13, okay, and wants to try at least 2 of each kind. Okay, so G has to be greater than 2, and then J has to be greater than 2. What would be the constraints that represent how many donuts the customer can buy? Well, we just wrote that out. Okay. So notice how, as I'm reading it, I'm taking notes the entire time. Okay. I do not expect you to be able to read this paragraph over 3 times and have it completely memorized. All right. Going on to the next one. All right, Billy is using this function to minimize, very important, his expenses when selling markers and erasers. He has the following constraints. What is the minimum value of E? Okay, so if I were doing this one, I would probably go into Desmos and then type all of these inequalities in. 3x plus y is greater than or equal to 5. 3x plus y is greater than or equal to 5. X plus 4 is greater than or equal to 4. Sorry, so popular, all the emails. And then greater than 0, greater than 0. Okay, so we're looking at this little area right here. This purple is what we're looking at, okay? And we're trying to minimize his expenses. Okay, so we're trying to minimize his expenses. That means that I'm going to try to pick something that makes the smallest amount of profit, okay, or smallest amount of expense. Okay, so let's try 0.5 and 3.5. Okay, so I could do X is 0.5 and Y is 3.5. Okay, so now if I plug those into both of these, or I'm sorry, if I plug it into this one, 1.89 X 1.89 times 0.5 plus 2.89 times 3.5, I would get 11.06. Okay, so that's one way. Okay, so one of my solutions, I got 11.06. Let's see if we can make it even smaller than that. Okay, so looking over here, well, what if I did 4,0? Okay, so let's plug in here. I would get 1.89 times 4 plus 2.89 times 0, and that's 7.56. So that's a lot smaller, right? So I would go with this one to minimize my expenses. I could also try this point right here, which is 0.5. Okay, so let's try that one. If I plugged in 0.5, that's 14.45. So that makes it larger. So best case scenario, in order to minimize, I would have to do 4,0. Okay, so coming back over here, what I would write as my final answer would be the minimum E value would be $7.56. Okay. What is the equation for the absolute value function given that it has a vertical shift up 8 and a horizontal shift left 3? Okay, so we're going to take absolute value. We're going to go into our Desmos and we're going to do a vertical shift up of 8 and a horizontal shift left of 3. So let's go in here. We're going to do the absolute value. Remember, in order to do that, you're going to hit shift and the little back button, like the backslash button. And we're going to do X. Now, in order to move it left 3, what if we subtracted 3? Well, that moves it right? So instead of minus, it's going to be plus, okay, because it's opposite inside of the parentheses or the absolute value. And then we're going to shift up 8. So that would be my equation for this absolute value function. Okay. We're going to come back to number 5. I'm going to talk about this a little bit later. It might have its own video as well, but we'll come back to that in just a second. Okay, on the next one, it says, does the following system of equations have a solution? How do you know? So you're going to take both of these and plug them into Desmos and see if they can cross out over at all. Okay, so we've got x squared times 1/9 x 1/9 x plus 2. There we go. Okay, and then we're going to graph the other one, which is ln of x plus 7 plus 4. All right, so where do they intersect? Well, they intersect here and they intersect there. Okay, so as my final answers, I would write down negative 1.771 and 1.679. Because remember, when we're dealing with like not inequalities or whatever, then we're just dealing with our X values. Now, does this system have a solution? Yes. And that's where it crosses over. So if they ask you, how do you know? That's where the graphs intersect, or you could say graphs cross. Okay. This next one, again, we're going to plug into Desmos. We're going to see where they cross over. So you got ln of x plus 2 minus 6. Ln of x plus 2, 6. And then you've got x cubed minus 10x plus 7. X cubed minus 10x minus 7 plus 7. Okay. And we're trying to see where their solution is. So we got 1.53 and 2.146. So 1.536 and 2.146. Again, we're just referring to the X values on this one because we're dealing with functions. Now I asked, what's the smallest solution? Okay, and what I mean by that is, what is the smallest number? Be mindful of your negatives, okay? Don't mess that up. What number is smaller here? Well, 1.536 is, okay? Number 8, it's missing a picture, but basically what you're going to be asked to do is, what are the equations for the graph? So you're gonna be given like a piecewise function. So I'll draw one out on here for you. And then we're gonna write the actual equation out. So let's say I had something like this. I had from here to here, and from here to there, and then I had an open circle. All right, so let's say that this is my graph. It's a little ugly, but it's okay. All right, so let's switch these two. Okay, so if I had this little graph right here, it's gonna be an open circle, and this is gonna be a closed circle. Okay, I'm gonna start off with this dot right here. Well, this is -2, 4, 6. So that point right there, when x is equal to -6. Actually, we're gonna do a line up here. Sorry. There we go. Okay, so when x is less than or equal to 6, -6. And we see that at y equals -2, -4, -6, y equals -6 is just kind of going off, right? Now from x is greater than 6, -6 to 0. Okay, so let's actually write that out. X is greater than -6 to 0. Then what's going to happen is you've got a constant at y equals 0. Okay, then we've got this equation. Now I didn't draw this line super straight, but if it goes up 2 and over 2, that's going to just be y equals x. So this line is going to be y equals x. And that's going to be from 0 to 2, 4, 6. So we're going from 0 to 6. Okay, and then this one right here, if I actually connected the line and drew it all the way through, I'm actually going to do this in a different color so you can see it. So if I had this exact line, this is a horrible drawing, and I went all the way through, okay, then Okay, that means that I'm gonna have y equals negative x plus 10. Okay, and we can actually see, because my drawing skills was horrible just a second ago, that these lines intersect in a different place. So I'm gonna redraw this line, and I'm so sorry. Okay, so this is gonna be like this, and we can already see that this is gonna intersect right here. So this is actually gonna happen at 2, 4. It's gonna be at 4 instead of 6 on the last one. Okay, and this is happening from 4 to 10. From 4 to 10. Now remember, if it has a closed circle, it's going to be an underline. If it has an open circle, that's going to be no underline underneath. Okay, so that's something to keep in mind. And I'm so sorry for that bad drawing. And let's go ahead and take a look at the next one. So what is the graph of the following function? Again, this is just going to be put it into Desmos. So for absolute value of x plus 5. So this is what the graph will be. So on your test, you will actually have to recognize the graph. You won't have to draw the graph, but you have to recognize what it looks like. Okay. So I'm going to end the video here and then pick up on the next question in just a second.